Hi everyone, in this video I want to talk about finding angles of right triangles using trig ratios. Here are the two problems that we'll do. And to make sure we don't take ourselves too seriously, let's think about the fun question. If you had an entire day available to work on your hobbies, which would you pick? So let's think about this topic, and that is nested under trigonometry. So not only are you using the trig ratios for the setup, but you are also doing it with right triangles. Okay, so it's, on the ACT, you'll see only a few trig problems total, but it's common that you would see something related to this or solving for a side like I have in a different video. So this video is the follow-up to the side video. In that one, I also started with so, ka, toa, and that is sine equals O over H, cosine A over H, tangent O over A. Okay, so in this first one, we are asked to solve for angle B. The theta is in the B area. Okay, so we need to try to find that angle using the 3 and the 6. So let's label the 3 with an O because it's opposite from the theta, and then the H is the 6. So which trig ratio involves an O and an H? The sine. Remember, it always goes sine, then angle. The angle we don't know, and then it goes O over H. 3 over 6. Okay, so now here, we don't know the theta, and that's what we have to solve for. The only way to do that is not to divide by sine, which is what a lot of students think you need to do. Sine and theta are married right now, you could think of. And we do need to split them apart, sadly. Sine inverse is what we need. So a sine inverse is the only thing that can take the sine away from the theta. And so theta now is equal to the inverse sine of 3 over 6. And that's what you can just type in the calculator. For a TI-84 calculator, that would just be second sine. So, and yeah, that's pretty common for most calculators. For this one, you end up getting a whole number. That's just 30 degrees. Okay, so that means 30 degrees is that theta. For number 2, we have matching 7s, and that might jog your memory from geometry. If you have lengths for the legs that are the same, you might be thinking, oh, then this is just 7 root 2. So to find that theta, we might just call this, if that's 7, that's 7, this is 7 root 2, that means this is 45 degrees. Oh, because it's a 45, 45, 90 triangle. So that's something you can have in the back of your mind when you use a trig ratio to set this up and check that. So that's why I chose this for number 2. Let's label our O, A, and H. That's how I always I always do these trig problems with that. Across from the theta is the O. Next to the theta is the adjacent. Adjacent means next to. And so we have an O and an A. So tangent something equals 7 over 7. Okay, tangent inverse. On both sides, those two cancel out, and we get theta equals, and then if you type this in the calculator, tangent inverse, and that's 7 over 7, or just 1 whole, theta is equal to an even 45 degrees. So yes, that is true. We could have used special right triangles, and also we could have used that in this one too, if you noticed that double the 3 is the 6. So So yeah, that's why this degree here, the theta was 30. So let's do a little practice. These problems are very similar to the ones that I just did. Their answers, though, that you'll see in a second, they do need to be rounded to the nearest tenth. Let's pause for a second if you need to do these before seeing the solutions. Okay, there they are. So I will leave you with a quote. I think about this one a lot. Sometimes you're the windshield, and sometimes you're the bug. I think about this whenever I need a dose of humility or just some perspective that things don't always go how you want them to. Sometimes we are the bug. So I hope this video benefited you in some way. And if you think of your answer to the fun question, I'd love to see it in the comments. If you don't mind subscribing to the channel, you can keep up with the videos. And I hope you have a wonderful day.